Hey guys, I'm up here today. Today we're talking about applications of absolute value. It should be a pretty quick one, and we're not really going to have a homework assignment for this, but I wanted to show you some applications that we can have before we go ahead and start reviewing for our test. What I mean by applications is some real-world applications for our absolute value graphs and functions. So let's first take a look here at number one. So number one says yard lines of a football field have the relationship shown in the table below. Okay, this all makes pretty good sense. Our distance from the end zone, uh, as our distance from the end zone, we go 10, 20, 30, 40, 50. But whenever we hit 60, it starts going back the other direction. It goes 40, 30, 20, 10, 0. And so we can almost think of it being like an absolute value from the 50-yard line because we're counting both directions. So let's write an absolute value function to find the marked yard line for a given distance from an end zone. Okay, so let's go ahead and start off by graphing the ordered pairs on this graph that's been given to us here. So I'm going to start off by graphing out 0, 0. We're going to say this is my x and this is my y. So we're going to have a point first at 0, 0. There we go. Then let's have a point at 10, 10. Let's label this 10, 20, 30, 40, 50, 60, 70, 80, 90. You get the idea. Okay? Same thing goes here. We'll go 10, 20, 30, 40, 50, 60, and so on. So we're just counting by tens here. So as I go up, we're going to go 10, 10, put a point, 20, 20, put a point, 30, 30, 40, 40, 50, 50, 60, 40. So we'll go 60, 40, 70, 30, 80, 20, 90, 10, and 100, 0. So you can see how I have created this absolute value function. So now let's write an equation for it. So the first thing that I need to do is find my h and my k. Remember what my absolute value function is. It is y equals a times the absolute value of x minus h plus k. For this particular problem, we don't really need to worry about b at all. So we're going to go first find my vertex. So we're going to say, what is my h value? My h value is going to be whatever my axis of symmetry is. And my axis of symmetry is right there in the middle at 50. So my h is 50. Let's see what my k is. My k is going to be how tall it is, right? And so my k is going to be at 50 as well. So we're going to write this out. But then we also have to think about one last thing. Is my graph opening up or is it opening down? Yeah, it is opening down. So my A is going to be -1. So when I write out my graph, it's going to be y equals -1 times the absolute value of x minus my h, which is 50. When I put it into my equation, it becomes a liar, plus my k, which is also 50. So there is my equation. All right? So there you have it. Now, let's try number 2. So number 2 reads, you are trying to make a hole-in-one in golf. I guess putt-putt golf. Imagine that a coordinate plane is placed over the golf green. Okay, that's pretty easy to imagine. The golf ball is at the point 2, 2. So we can say this golf ball, when it starts, is going to be at 2, 2. Okay? And the hole is at 8, 2. And you are going to bank the ball off the side of the wall of the green at 6, 8. And so we're going to write an equation for this path of the ball. Then we are going to ask ourselves if we made the shot or not. So first and foremost, let's find what my h and k is. So obviously, my h is going to be, that's going to be where my axis of symmetry is. So my h is going to be at 6, and my k is going to be at that highest point, which is 8. So once I know my h and my k, we're doing pretty good. But now I need to find what my a is. Now I know one thing, my a is going to be negative. But one thing I don't know is the slope that my graph is going off of, and that's very important. The angle that we shoot off that wall is just as important as the point at which we're at, right? Because that's showing where we're going to hit, if we're going to hit that hole or not. So to find my a, I need to find my slope. And to find my slope, remember your slope formula is m equals x1 minus x2 over, oops, sorry. It is, do that backwards. It should be y1 minus y2 over x1 minus x2. So there you go. There's our y1 minus y2 over x1 minus x2. So we're going to take our 2 points. I'm going to take 2, 2, and I'm going to take this point, 6, 8, to find what angle, what slope we are at. So we're going to say 2 minus 8 over 2 minus 6. Well, 2 minus 8 is negative 6. 2 minus 6 is negative 4. So we're going to have negative 6 over negative 4 is a positive 3 over 2. So there's my slope, 3 over 2. And I know it's negative because my graph is opening down. Okay, so if I know all of that, I can write my equation. I can say y equals negative 3 over 2 times the absolute value of x minus my h, which is 6, plus my k, which is 8. There's my equation. Okay, let's see if I make the shot. What we can do to make the shot is we can see, does 8, 2 plug in and work for in my equation? If I plug in 8, 2 into my equation, does it work? So let's see here. I can go y equals negative 3 over 2. But instead of having a y here, we're going to plug in instead, 2. And instead of having an x here, we're going to have 8. So we're going to go 8 minus 6 plus 8. And we're going to work this out and see if it equals. Okay? So if I go 8 minus 6, that is 2. 2 times negative 3 over 2. 2 times negative 3 over 2 is a negative 3. Negative 3 plus 5 is, 5. Man, 5 doesn't equal 2, so no, this is not going to be it. So we're going to say, no, we don't make the shot, which is just too bad.